Hi everyone, welcome to Smart Classroom. This is Mahammood Suhail Mundodan. Let's come to our second series. Our next topic is conductors and insulators. What is conductors? The conductors are the substances which allow electricity to pass through them easily, are called conductors. Insulators are the substances which are high resistance to the passage of electricity through them. Examples of conductors: metals like copper, aluminum, silver, human and animal bodies, and even earth are very good conductors. Non-metals like glass, plastic, nylon, wood are the examples of insulators. Availability of charge carriers. In conductors, there are enough free electrons are available, which are free to move inside the material, so that conducting process is very easy task in conductors. What about insulators? In the case of insulators, electrons are tightly bounded with the atom, and it is not available for conduction. What will happen when we transfer some charge to the conductors and insulators? If we transfer some charge to the conductors, it gets distributed over the entire surface of the conductor. But if you transfer some charge to an insulator, it stays at the same place without any distribution. What will happen during rubbing? If we rub a plastic comb with dry hair, the comb gets electrified, but it does not take place in a metal articles like spoon, because the charge on the metal leaks through our body to the earth, because both our body and spoons are good conductors of electricity. Next topic, grounding or earthing. Suppose when we bring a charged body in contact with earth, all the excess charge on the body disappears by causing momentary charge to pass through the ground through connecting conductor. This process of sharing charges with earth is called grounding or earthing. Grounding is a safety measures for all our electrical circuits and appliances. The electrical wiring in our houses has three wires called live, neutral and earth. The first two carry the electrical current from the power station. The third one is earthed by connecting it to the buried metal plate. It is used in all electrical appliances such as refrigerator, iron box, TV, etc. are connected to the earth wire. If any fault occurs on the metallic body, the charge flows to the earth without damaging or causing injury to the human body. Next topic is charging two spheres by induction. In last class, we already discussed charging a metal sphere by induction. There you might be noticed, when we remove a charging rod, the charge on the metal sphere rearrange themselves and become neutral again. In this example, we will discuss how we can charge two conducting sphere permanently. Here we have two metallic sphere A and B supported on insulating stand, touching each other. When we bring a positive charge rod near to the sphere A without touching each other, the free electron in the sphere A are attracted towards the rod. This leaves an excess of positive charge to the surface of the sphere B. Now we separate the sphere by a small distance, while the glass rod is still held near the sphere A. You can see that all the negative charges are trapped inside the sphere A and all the positive charges are trapped inside the sphere B. Now the two spheres are found to be oppositely charged and attract each other. If we remove the rod, the charges on the sphere rearrange themselves. When we separate the two spheres quite apart, the charge on them get uniformly distributed over them. In this way, we can charge two spheres by induction. Next topic, charging a metal sphere positively without touching it. In this example, we will discuss how we can charge a metal sphere positively without touching it. For this purpose, take an uncharged metallic sphere on an insulating metal stand. Bring a negatively charged rod close to the metallic sphere. As the rod is brought close to the sphere, the free electron in the sphere move away due to repulsion. The near end become positively charged. This process of charge distribution stops when the net force on the free electron inside the metal is zero. Connect the sphere to the ground by a conducting wire. The electron will float to the ground while the positive charge at the near end will remain held there due to the attractive forces of the negative charge on the rod. Disconnect the sphere from the ground. The positive charge continues to be held at the near end. Remove the electrified rod. The positive charge will spread uniformly over the sphere. Next topic, basic properties of electric charge. Here we are discussing 9 properties. First one, like charges repel each other. Positive and positive will repel each other. Negative and negative repel each other. Second property, unlike charges attract each other. And the third property is charge is additive. We already discussed that small q is the individual charges and capital Q is the sum of the individual charge of a substance. That means capital Q equal to Q1 plus Q2 plus Q3 etc. So the charge is additive. That means total charge of the substance is the sum of the individual charge. Here we have a metallic balloon. It's having 3 different charges Q1, Q2, Q3. Q1 having plus 3 charge, Q2 having plus 1 charge and Q3 having minus 2 charge. Then capital Q represents the total charge of the metallic balloon. Capital Q equal to the summation of total charges, that means Q1 plus Q2 plus Q3. You just add the individual charges. Charge of the metallic balloon equal to plus 2. That means the charge is additive. The next property is charge is quantized. The quantization of electric charges means all free charges are integral multiples of the basic unit charge of an electron, represented by small e. The charge is always represented in the form of capital Q equal to Ne. The magnitude of electronic charge equal to 1.602 into 10 to the power minus 19 coulomb. This is called quantization of charge. SI unit of charge is coulomb. Here the total charge of the substance capital Q can be expressed as the integral multiples of the electron. That means capital Q equal to N into E, where Q is the total charge and small n is the number of charge particle exchanged and small e representing the charge of the individual charged particle. It may be a proton or electron. If small e is positive, then capital Q will be positive. If small e is negative, then capital Q will be negative. The basic cause of quantization is that only the integral number of electrons can be transferred from one body to another on rubbing. Next property is charge is conserved. By the laws of conservation, energy can neither be created nor be destroyed, but it can transfer from one form to another. The same theorem is applied here. In the case of a friction, there is a mutual exchange of charge is taking place. That means one object loses electron and another object gains the electron. Do you know how the charge is conserved in this process? Gain of electron equal to loss of proton and loss of proton equal to gain of electron. The loss of one charged particle is replaced by the gain of another charged particle which is oppositely charged. This is called conservation of charge. Next property is charge is invariant. The magnitude of the charge is not changed with respect to the change in the velocity. It is called invariant of charge. Whatever may be the velocity of charge, the magnitude of the charge is not going to change. But it does happen with the time and length. This we already studied in your +1 syllabus. Next property, charge at rest can produce only electric field. The eighth property, charge in motion can produce electric field as well as magnetic field. The last property, the charge is distributive. It means that charge can be distributed over the surface of the body, along the length of a body, or over the volume of the body. That's all for today. If you have any query regarding this topic, you can comment me under the comment section. If you like this video, please subscribe and share. To get all our notifications and updates, don't forget to press the bell icon. Thanks for watching. See you next time.